Hello everyone. In this video we will discuss about chemical equilibrium. But before we discuss chemical equilibrium, we gotta discuss a couple of other things, which is type of reactions. There are two types of reactions in the broad categories. One is we categorize them as irreversible reactions. So irreversible reactions are the reactions that can goes only one direction. Like you cannot uh, undo whatever you have done. Like this way. You make dough from flour, right? So you cannot bring back the flour from dough. So that's an example of irreversible reaction. So making dough, burning fire, because you cannot go from ashes back to wood. So these are example of few irreversible chemical reactions. So, but what is a reversible reaction then? So a reversible reaction is a reaction that can go on either side. So let's say if we have a reactions, if you have reactions where A is changing into B, well, after a certain point of time, B can also change back to A. So do you get the idea? So it can go either direction. So it's a two-way lane. So A can change into B, or B can change back to A. So for these type of reactions, let's have an example. So let's say we have sulfur dioxide that is reacting with oxygen, and that is making sulfur trioxide. So first thing that we have to do is we have to balance this equations. So we gotta add 2 here and 2 here. I think that should balance things out. 4 to 6 oxygen, 6 oxygen, 2 sulfur. Okay, so that is a balance equations. So in this particular example, if we mix sulfur dioxide with oxygen, after a certain point of time, what's going to happen? So these are our reactant, and this is our product. So let's give a different color. So this is our product. So let's say you started with 100 sulfur dioxides and oxygens, maybe 200 of sulfur dioxides and 100 of oxygen. So 200 of sulfur dioxides and 100 of oxygen. So let's monitor this reactions based on how much sulfur dioxide we have added. So you can see if we plot a graph. So initially you have a lot more reactant, right? So yellow is our reactant. So initially you had a lot more reactant. So what's going to happen as time progresses? So this is our time. So as time progresses, the amount of reactant would go down. Same thing will happen, but in the opposite directions per product. So initially you didn't have any product, so it's gonna go up, and after a certain point of time you will notice that the amount of product formed is staying constant. So this is amount. On your y-axis is amount of reactant or product, PDT. So you can see after a certain point of time the amount of product is not changing. Also you can see after a certain point of time the amount of reactant is not changing. So this is the step where we call the reaction is achieved equilibrium. So equilibrium means where things are balanced. So if we consider forward reaction, so the forward reaction is going from left to right. So that's called forward reactions. And going from right to left is called backward reactions. Maybe I should give a little bit bigger arrow here. Let me redraw this. So the forward reaction is going from left to right, and the backward reaction is going from right to left. Okay, so for backward reactions, what's happening in the backward reactions? In the backward reactions, you have 2 of sulfur trioxide is dissociating, is breaking into sulfur dioxide and oxygen. So if a reaction is in equilibrium, if a reaction is in equilibrium, the forward reactions must match with the backward reactions. So once the reaction reaches to that equilibrium spot, the rate of forward reactions equals to the rate of backward reactions. So okay, so this is the equilibrium stage where rate of the forward reactions is equals to the rate of backward reactions. So in this case, what is happening is maybe 200. So let's say the equilibrium is achieved, and what happened if you have 2 of sulfur dioxides is reacting with 1 of oxygen to make up 2 sulfur trioxides, but immediately 2 sulfur trioxides is dissociating back to sulfur dioxide and oxygen. So it's the equal, everything is balanced. So that's where you reach the equilibrium. So you can see here the amount of reactant and the amount of product, it doesn't change, but the reaction is still continuous, it's still going on. What is happening is just the forward reaction rate is matching the backward reactions rate. It's like someone is, so this person's here is pulling to this side, and this person here is pulling to the other side. So let's have another person's. So this person is pulling to the other side. Although the center line, it doesn't move, but they are still pulling. So there is still reaction happening on either directions, but the center line doesn't move. So that's pretty much what happened. Once the once the equilibrium is reached, uh, the concentration of reactant and concentration of product, it doesn't change.